Hi everyone, thanks for joining us here today. So Greg and I today will talk to you about intersection at the center of this Venn diagram. We'll talk to you about Netflix, we'll talk about AWS of course, and we'll talk about Cassandra. Specifically, we'll talk how Netflix uses Cassandra as a persistence layer to store our data on top of AWS. So what we're going to do is, I'll start with a little introduction, do a little bit overview of Netflix. I'll hand it over to Greg, do a deeper dive into our Cassandra operating practices and how we optimize Cassandra for our needs. And then I'll close it up with some performance evaluation and then briefly talk about some of our open source offerings that are related to Cassandra. So if you don't know who Netflix is, we allow more than 30 million people worldwide enjoy TV and movie entertainment as subscription service. So why cloud? Some background information. Sometime in 2008, Netflix experienced about 1 week outage. That at the root cause of it was a data corruption in the Oracle database. Shortly after that, the popularity of our subscription service started growing at a very rapid pace. This graph illustrates the pace at which it was growing. And early in 2009, we very quickly realized that we just would not be able to keep up with that pace in terms of building up the data center capacity. Moreover, we realized we were not in a business of building out data center capacity. We were in a business of delivering entertainment to people in terms of streaming experience. We didn't have the expertise, capability, or motivation to start building out physical data centers who can have power, racking up servers, etc. So we looked and decided to migrate to the biggest public cloud provider out there, Amazon's Web Services. And over the last 2.5, 3 years, that's exactly what we've been doing. We've been slowly migrating bit by bit our infrastructure and product components from data center into the cloud. We couldn't just pull it as a binary switch. There had to be a lot of transitional infrastructure to be built up. Internally, we refer to this process as Roman riding. Those of you unfamiliar with the term, this is when you ride 2 horses, 1 leg on each horse. Somewhat tricky, sometimes somewhat painful process. And when we were migrating our infrastructure, the stateless applications went first because those were easiest to migrate. And data is the trickiest one to migrate. So we had to build sometimes one-way mirroring data pipelines. Sometimes we even built a multi-master mirroring pipelines, which were definitely part of the trickiest parts. So at this point, Netflix is, sorry, I'm having issues with my clicker here. There we go. Netflix, all of our services are pretty much running in the cloud. There are some small billing and payments related components and data sets that are still in data center, and we're working on making SOX and PCI compliance for those components, and when that's done, we'll migrate the remaining infrastructure. All of the international product currently is fully cloud-based. That means if our data center for any reason goes down or network to it is severed, all of international customers will be able to stream movies without any interruption. So enough with the overview. At this point, I'd like to turn it over to Greg, who runs our DevOps team, and he'll take you deeper into what we do with Cassandra.
Thank you. Quick show of hands, how many people actually use Cassandra in AWS? Very nice. So my name is Greg Ulrich. I am a member of the Cassandra DevOps team. We are responsible. If you attended either of Adrian Cockcroft's HA presentations, if you're lucky enough to get into either of those in the last couple of days, it's probably surprising to hear to you that we have a dedicated, somewhat centralized operations team in Netflix. And that's essentially what my team is. We are responsible for all the Cassandra clusters that we use to serve production streaming Netflix service. Pretty much every service that Adrian told you about is backed by Cassandra. And the reason why we have a centralized operations team is to remove the need for people to understand how Cassandra works and just have them free up to use the service. So the way the service we try to provide to people is to make it more like an extension of an AWS service. Like, I really don't know how S3 works, what they do behind the scenes, but I know I can put files on it and I can take them off. We try to do the same thing with Cassandra. So what is Cassandra? It's a database, right? It's NoSQL, it's persistent, it's a key value store, but it's really just a database. You put your data in, you get your data out. It's eventually consistent, so you may not get the data out that you put in right away. But if you've written it, rest assured it's there. Why did we choose Cassandra? It's open source and written in Java, and we really like open source projects. And Java. The big selling point for us was its multi-region replication. Back when we started in Cassandra, we were a US-only service, but we knew ultimately we were going to be international, and we needed the ability to get our data replicated wherever we were going to have a service. As I mentioned, most of the services now are backed by Cassandra, and we do it for offline data computation, for subscriber information, playlists, bookmarks. We use it for everything, and the nice thing about Cassandra is it supports a wide range of use cases, so we've yet to find something that we couldn't model and run properly in Cassandra. It runs on commodity hardware, which to me, when I think of commodity hardware, I think of AWS, and we haven't run into any issues with that. And it's been enhanced to understand the AWS topology, so Cassandra knows what an availability zone is, and knows what a region is. That stuff has been built in, or at least built on top of the product. And it's very durable. To talk to durability, there's no single point of failure or specialized instance. Every instance in a Cassandra ring does essentially the same thing. There's no name nodes that when they die, your cluster goes away. It stores multiple copies of data across availability zones, at least in the way we configure it. And I'll show you that later. But the fact that it handles all that replication for us is a big selling point. And it makes the data that much more durable. It has features built into the architecture like bootstrapping and hinted handoff. So if your writes do fail or your nodes fail, you're going to get that data back. Once your data is in Cassandra, it's very hard to remove it. Or it's very hard to have some type of issue happen with your cluster, remove that data. All the writes are appended to a commit log, so your history is pretty much there. And it has asynchronous cross-regional replication, which we take advantage of in our UK or EU service. So how do we configure Cassandra in AWS? Cassandra is essentially a ring structure. Each node in the cluster has a token associated with it, which determines when your key is hashed, which node is going to get the data. We're looking at a typical configuration for one of our multi-region clusters. 12 nodes in US East, 12 nodes in EU West. You'll notice around the ring that we alternate the availability zone all the way around the ring. So we don't have the same availability zone next to a node anywhere around the ring. And what that enables us to do is when a write comes into a coordinator and it gets written off to 3 nodes, you'll see that one copy of the data is in each availability zone, both in the US and asynchronously into the EU. So we have our data in multiple data centers. So if we were to lose a node, this way, we still have 2 copies of our data. And since we still have 2 of our 3 nodes, we're still able to satisfy quorum, both read or write. We typically do write, quorum, and read 1 at Netflix. But we don't worry when a node goes down because we're going to have 2 copies of our data. In fact, we don't really worry if a whole availability zone goes down. So if one C goes down, and I'll talk a little bit about a recent outage. If we lose an entire availability zone, we still have 2 copies of our data everywhere, and we're still able to satisfy quorum because we haven't taken out more than 1 node in any replication set. Where we get into trouble, and this doesn't happen very often, is where we lose consecutive nodes. This is sort of the Achilles heel that we've run into. When this happens, you're not able to satisfy quorum, and you're actually not satisfying it on 2 replication sets, this one and this one. So when that happens, you're going to have a partial outage. So your writes, depending on what your quorum consistency level is, either your reads or writes will fail. We also back up all of our data to S3, a local region, same account version of S3. We do that in 2 different ways. We have a full backup, which we take a snapshot once a day, copy all the files to S3. And we take incremental backups, which every time the memory is flushed to disk and a new SS table is created, we copy that file over to S3. So we're able to restore clusters to as real time as eventual consistency will allow you to a point in time by starting at a full and going incremental up to a certain period of time. We also we have an additional copy of our data in another region and another account. So if a region goes down, we still have our data somewhere. And if someone deletes our account, we still have our data somewhere. We use mostly M24 XLs, but now that the SSDs are available, we're moving to them. And Russell will talk a little bit about the performance we get out of SSDs, but as a teaser, it's great. But we find that M24 XLs are working well for us also. We use ephemeral storage for better performance. We made a lot of these decisions before the high provisioned IOPS EBS volumes came out. So I can't speak to the performance of ephemeral versus those, but ephemeral has been good enough for us, and we're sticking to it. We use multiple ASGs, or autoscaling groups, to create a cluster. We don't have one cluster that's made up of multiple availability zones. We have multiple autoscaling groups that have one availability zone each. And I think I touch upon this later. Yeah, or maybe I should do it now. I'll do it later. The reason we do that is we want better control over how AWS spins up nodes. Like, we want to know, we don't want AWS to do node balancing across availability zones for us, because we care how many nodes we have in a ring, because we want things to be configured properly. We have single tenanted clusters mostly, so every service gets its own Cassandra cluster. That was an early decision we made because we started with Cassandra with 0.7, and we did it somewhat we didn't do it tentatively enough, but we at least wanted to mitigate risk of one service bringing down another, so we just created a bunch of Cassandra clusters. And we tend to over-provision them. I don't know that we've figured out the sweet spot for how to provision Cassandra clusters yet. We tend to over-provision in case we lose a larger number of nodes or lose an availability zone. We want to be able to have enough capacity to serve what we would expect to be full load from all the services. And I'll talk about that later when I discuss a recent outage. So let's talk about some of the optimizations we do. We have active Cassandra, I guess they're not official committers, but people who are working on the code. They're making bug fixes, performance changes, security. We checked in the code that does the asynchronous replication to other regions. We implemented something called snapshot repairs, which is a way, less I/O intensive, but somewhat longer way to repair your clusters by not running, how does it work? By not running repairs in tandem on as many machines, by not running the repairs, by sort of spreading out the repairs across the different machines. Sorry.
This backup you mentioned to stream on the SSD are pushing. Is this something you will build into Cassandra itself, or you do outside?
I will get to that. The question was about how we implement backups, and I'll cover that in a future slide. Is that the one I wanted? Sure. So we weren't completely happy with a lot of the Java clients that were out there, so we built our own. It's multi-region and zone aware, so if we have a client coming in from EU or US East 1A, it's typically will be sent to an EU East 1A node in Cassandra, so you're not doing a hop to another availability zone. And it's also latency aware, so it will recognize that we have some nodes that are slow and start sending traffic there, on top of however Cassandra manages that. It has a Fluent API that's built on top of Thrift, and given that we have so many use cases internally, we have a great set of best practice recipes for others to use. A lot of things bother me. I don't like when people don't use their turn signals, but the thing that bothers me almost as much is the assumption that Cassandra is hands-off operations, that pretty much all you have to do is throw some clusters out there, it's going to run, and if you don't have enough capacity, throw some more out there, and it's going to run. Like, that's really not true. We put a lot of work into building tools to mitigate a lot of the headaches of managing a Cassandra cluster. So we have a Tomcat web app that we use for Cassandra administration, and the nice thing is it has AWS-style instance provisioning, so all I have to do to create a cluster is launch a bunch of nodes in AWS. And it uses a lot of the infrastructure and tools that we have built into it to spin up a cluster. So if I want a 6-node cluster, I'm not configuring Cassandra YAML files or figuring out what my tokens are. I'm just saying, AWS, give me these 6 nodes, and by virtue of what's on the AMI, I'm getting a ready-to-use Cassandra cluster. And the same thing for when I have to swap nodes out. We swap nodes out a lot. I think I cover this later, but pretty much with the admin web app that we have, killing a node and having AWS spin up another one is essentially a no-op for me. It's going to join the ring. It's going to get the right token. It's going to stream all the data. It's going to be brought online. We do full and incremental backups, and this is built into the web app that we use. So I believe that Cassandra will do the incremental backup for you. There's a configuration in the YAML file that'll say enable incremental backups, and they'll copy those SS tables to the backup directory and the data directory. But we have the tool that we wrote will take those, watch for things that change there, and upload them to S3. We do JMX metrics collection. We get a lot of metrics out of Cassandra. We're starting to scratch the surface of understanding what they mean towards the health of the cluster. I'll talk about that a little later. But the application that we have is pulling all that stuff and graphing it for us. It enables us to configure our clusters consistently with some tuning. It's got a great REST API to most of the administrative options, so rather than connecting to a node and running node tool ring or node tool repair, we could do it all via REST API. And it does great security group configuration for us, specifically with respect to multi-region. So as new nodes are spinning up in multi-regions, it's important that all those nodes can talk to each other instantly. As new nodes spin up, we will recognize that we have a new node in EU and instantly configure our security groups to ensure that when that node joins the ring, we're going to be able to communicate with it. So once people figure out how to set up Cassandra and they get a bunch of data in there, a lot of the questions I'll see on the user group is how do I actually view my data? And I think a lot of people, there seem to be a lot of organic tools that people are starting to develop for a graphical representation of your data, and we have one too. It's sort of the missing UI for Cassandra client users. It allows us to view and edit schemas so we can see, we can create new key spaces, column families, edit the ones that we have. It allows us to do point queries and actually update the data. It gives us high-level cluster status and metrics across all the different clusters we have, integrated access control. So if you attended Adrian's talk, we're big on freedom and responsibility. And on the ops side, what's hard for me is not knowing when people are making schema changes and the impact it has on me. Someone might push out something new. I had no idea about it. They turn on some new service. It spikes up the traffic 10x. The cluster starts to fall over. Via schema auditing and integrated access control, it gives us a couple of knobs, or at least early warning, well, real-time warning signs that something is being changed on a cluster, and it gets us that much closer to real-time understanding of what's happening on the cluster. So here are some screenshots. Hopefully they look better up there. This is the circles represent all the different Cassandra clusters that we have. The segments of the circle are the instances. The different color green are different regions. Note the segments that are red are nodes that are down. We take nodes down via Gossip a lot to do some maintenance on them. Nodes that are yellow are ones that are potentially under stress. Right now, if it has a heap over 75%, it'll turn yellow. And this is, we've had this up on the wall before. It just gives us sort of a overall state of what the health of our clusters are. This is the data query tool. Probably hard to see. You can pick your column families. You can put some filters on it, and it'll display all the data for you. And I'm pretty sure, although I've never done it, you can edit the data through the same interface. And here's our schema management tool. You can create a column family, pick your types, and you could change existing data structures as well. And we audit all these changes, so we have good visibility into what's happening on the clusters. So let's talk a little bit about operations, in particular how we dealt with the June 29th outage. Anybody here remember the June 29th outage? I know you do. Yeah. So a big storm hit the East Coast, took out one of the data centers in Virginia. I think they're somewhere under there. We had a temporary service outage. But via our Netflix tech blog, Cassandra dealt with the loss of 1/3 of its regional nodes without any loss of data or availability, and that's very accurate. Like we never lost any of our data, even though we lost 1/3 of our nodes, and we never lost any of the availability. The availability is, a lot of the services were down at this time, so the amount of traffic we were getting was nominal compared to what we usually get. So saying that we were available through this is sort of a cheat. Yeah, but I think the important thing to note is that as all these other services spun up, and I think during this outage, a lot of the services were starting to spin up nodes in the regions that were available. Cassandra, since we over-provision, since we configure our availability zones properly around the ring, we were constantly available, and we constantly had all of our data. So what happened during the outage? Power outage in US East 1. When we got our ring status via node to ring, it showed 1/3 of the nodes were down. We weren't worried about this because of how we configure our clusters and because we over-provision. But it was really important for us to maintain quorum everywhere, so we started watching our other availability zones a lot more closely than we would to ensure that we weren't having problems there. And then we didn't do anything, right? We don't do anything when we lose an availability zone. We sit around, we let the other services scramble to get out of that availability zone into the other one while we're just serving the traffic like we always do. We wait for AWS to fix the issue. AWS is great at fixing these issues. During the recovery, a bunch of the nodes came up, and most of the instances rejoined the cluster without any issue. They had their data, they joined the ring, they were 100% at capacity, probably faster than the services that they were serving. Some of the nodes required a reboot to fix. We really don't know why, but when we're dealing with tens of nodes and a reboot fixes our problem, we're happy to do it. And then we needed to replace a handful of nodes, most of which were fortunately in one of our internal monitoring tools. And what we did was we just killed those nodes, and because of the tooling we have, it just spun up another node in its place. So we really survived the outage well, and I think it was a great testament to Cassandra and its ability to deal with nodes being down, and the fact that we configure our clusters the way we do really helped protect us from this one and subsequent outages. Some observations about AWS. Again, we use ephemeral drives because we found it better than EBS before the high provisioned IOPS EBS volumes. Instances seldom die on their own. This was a surprise to me. I expected, when I got here, I expected AWS to be killing machines all the time, but they don't. We have tons of nodes with I/O issues that don't go away on their own. We monitor very closely for that, and when we find them, we shoot them and kill them. Our motto is, when in doubt, swap it out. If something's bad or something doesn't look right, it's better for us just to kill that node and have AWS give us another one, since we can replace it so easily. Use as many availability zones as you can. It's important to get your data in as many different places. You saw that it saved us in the June 29th outage. It could do the same for you. And I think a lot of the, through anecdotal reading, some of the other major services like the Instagram or whatnot, that were more affected by the June 29th outage, and don't quote me on the Instagram thing because I really don't know, might not have been in as many availability zones. I think it's important for you guys to understand how AWS launches instances. And this is why we went with the multiple auto-scaling group, single availability zone. When we started, we only had one ASG, and it had all the nodes in it. And AWS wants to keep your nodes balanced across all the availability zones. So if we say give us 6 nodes, it gives us 2, 2, and 2. And we can construct our ring properly. And at least this is back when we made the decision to go this way. It may be different now. But what happens when we had an outage is if we had 2 in A, 2 in B, and 2 in C, and A went down, we would lose those 2 nodes, and AWS would spin up a node in B and C. So suddenly our cluster isn't quite as balanced as we wanted it to be. But when A comes back online, it kills those 2 nodes and puts 2 A's back because it wants to keep those nodes balanced. And we don't want anyone messing with our nodes but us. We want AWS to have the right reason to kill it, not just to balance things. I think they might have, we talked to them about it, AWS might have changed this a little bit. But the reason we went with am I on our side? I guess I am. The reason we went with that is because we want more control over how, we want to control over how we want to control instances on our terms, not AWS's. I/O is constrained in a lot of AWS instance types. Even the M24XLs, when repairs and compactions run these operations that are very I/O intensive, it does affect latency. We had several issues early on when we were first getting our footing with Cassandra and AWS where large minor compactions kicked off on consecutive nodes in a replication set just brought the cluster to a crawl. The way we address those things is we run major compactions ourselves now. And as Russell will tell you later, SSDs, they are absolute game changers. The I/O is just so much better. On the Cassandra side, a slow node is worse than a down node. Kill nodes that are underperforming. Cassandra is the bootstrapping process of Cassandra is rock solid. It's going to get that new node in. But if your node is slow, we don't spend a lot of time trying to figure out why because we have infinite nodes. Cold cache increases load and kills latency. So when we spin up that new node, it's typically a little slow. We rely on the file system cache quite a bit. And as that's warming up on M24XLs in particular, your node is still going to be a little slow. So we got to let that thing warm up. We're looking into, well, apart from moving to SSDs, we're looking into ways to sort of speed up the cold cache problem. Cassandra, I guess it's on its way to 1.2 now. We're still on 1.09. I'm evaluating 1.1, looking to move there to 1.2. But it's still a relatively maturing product, and as such, it doesn't have a full suite of administrative tools for doing a lot of the operations or for dealing with issues when they come up. So it's important that you understand the few knobs that you have that you can turn when there's a production issue. Something we do often is take a node out of the coordinator list, so it's not serving coordinator traffic. It's still serving the reads and writes, but nothing is round robining to that node, which really reduces the amount of I/O on the node. Compaction throttling, if you're running really large compactions, you have the ability to throttle them, and you should. The min and max compaction threshold settings are this sort of magic way to make compactions stop. And there are times where you want them to stop without taking the node down, so you can use those. And enabling it and disabling gossip, just getting it out of the ring, that often helps. We use level compaction in some of our clusters. In fact, we're using it a lot more. And its performance is looking very promising. I think there are some, I would wait until 1.1 to use level compaction because they fixed some bugs. And I really think that's going to be a good game changer for us. And 1.2, we're really excited about because I think that's the vNode release, which will enable us to do behind-the-scenes auto-scaling for our Cassandra clusters. A little bit on monitoring. As I mentioned, we monitor hardware and network issues. We don't rely on AWS to kill nodes for us or to find problems. We want to find them first. So we do a lot of monitoring. We monitor dmessage, IOStat. If things are looking weird, we strongly consider throwing that node out. And we check the cluster consistency. Cassandra, all the nodes will gossip. You want to make sure all the nodes have the same opinion of what the cluster looks like. So we wrote this script that will go and check the ring status of all the nodes and make sure it's consistent across the cluster. We're starting to, so on the Cassandra side, we monitor throughput and latency. And we're starting to try to algorithmically weigh some of the different key Cassandra metrics, like whether or not your pending threads are queuing, or your dropping operations, or your SS table reads get high. We're envisioning some type of algorithm across, we used to alert off of every single metric, and that produced a lot of noise where there were problems. A big deal, Cassandra's compacting a lot. It's supposed to compact a lot, and if it's not affecting other things, it's really not that big of a deal. But in aggregate with other metrics, there's some algorithm that we're starting to hone in on that's going to tell us when the cluster is under a state of duress. And it's really going to be a weighted average of several different metrics. On the informational side, again, we want to know when the schema changes because schema changes don't go through us. We scan the log files for errors and exceptions. And we want, given the freedom and responsibility culture, anybody can really go to any node in Cassandra and do whatever they want with it. And in the past, we've caught people changing configuration changes and bouncing the node. And we don't like that. So while we really shouldn't stop them from doing that, at least by monitoring the restarts, we know that they do it, and then we can start asking questions. But it's amazing how people don't know. Like most people a lot of people don't admit to it. On the maintenance side, Cassandra's funny. They tell you it's very low maintenance, but you have to run repairs. And when you run repairs, you're trashing your server. But the only way to ensure that your data is consistent is to repair it. That's either via read repair or manual anti-entropy repair. So we repair all of our clusters as often as at least once a day. For clusters that take 3 days, we do it every 3 days or every n days. We run offline. While SSDs is making this unnecessary, we run offline major compactions to avoid latency. So that's a problem I was talking about where 2 large minor compactions came up and killed at least 2 replica sets. What we do is we will frequently, one node at a time, take it out of the coordinator list, take it out of gossip, run a major compaction, and then move on to the next node. Performance is so much better after it, but it comes with the price of if you do it once, you need to do it all the time. So once you start doing those compactions, you shouldn't stop. We always replace nodes when they fail. We periodically replace all the nodes in the cluster so that our data is consistent with all the other Netflix services. Because we're sort of built off of this base AMI model where there's a set of services we need for monitoring and other tools, plus our stuff on top of it. So we want to flush those nodes every now and then. We do two different type of upgrades. The rolling AMI upgrade is how we get new minor versions of Cassandra. And what we do in that case is we just kill every node in the ring one at a time, sort of spaced out, so we're not producing any hotspots. And we let Cassandra spin up a new node, and by the time we're done, run a new version of Cassandra. For major upgrades where streaming isn't compatible between versions, or you're in an emergency and you can't wait the 4 weeks it takes to upgrade our 72 node, 600 gig per node cluster, we do RPM binary upgrades. So I'm going to hand this back to Russell, and he'll tell you a little bit about performance and the open source initiatives related to Cassandra.
All right, so let's talk about performance. Performance for us in the database layer was very important. And so as we started evaluating various technologies, it wasn't just how fast it was at the time or how fast it was going to be, but how do we make it scale? It's one thing that if you want to scale performance of your database, you go to a bigger machine. That's a slippery slope, though, because eventually you're going to get to the biggest machine out there possible. And what do you do then? So for us, it was really important to find a technology that scales horizontally. And so early in 2011, we ran an experiment. We took a cluster, threw some load against it, measured the right throughput, and then progressively started doubling the cluster and measuring throughput against it. And so very quickly, we were able to achieve 1 million writes a second, which was really cool. And we only had to go, at the time, to a cluster of 240 nodes to get that performance, which was really cool. But what's most importantly, as you see from this graph, is not the absolute numbers, but the shape of it. It's linearly scalable. If you need to get more read or write throughput, you just add more nodes. And this is really important because your needs may change. Your needs may change over a day. And this is a really powerful tool to achieve the scaling needs that you get. Now, this was last year, as I mentioned, 240 node cluster, approximately 1 million writes. Recently, this year, we hit almost 1 million writes per second on one of our production clusters. Greg made me change.
We actually hit 1.2 the other week. Same cluster.
Yes, same cluster. So Greg made me change the title because at the time he didn't want to commit to that 1 million, but let's say close to 1 million writes a second. What's important about this? This is a 72 node cluster. Same machines, M24 XLs. So what changed in a year? Well, Cassandra's technology definitely evolved. And over a period of 1 year, definitely performance improved. We also like to think that we gained some learnings and learn how to configure and tune the performance out of Cassandra a bit better. The significance of this number, 800, anyway. SSDs, huge game changer. So before I dive into the slide, one of the major reasons why we wanted to go to SSD was to relieve some operational pains. Repairs, compactions are extremely latency disrupting operations. You start running it, and your client latency average 95th percentile, 99th percentile jumps up. If you attended Adrian's talk, that you know that we run a lot of the microservices. And each of those service applications is very latency sensitive because it needs to get downstream response fast so it can do its own logic and then the return response back to the upstream client. And so they have very aggressive timeouts. Most of them have that timeout set for the downstream response to either low double-digit milliseconds or sometimes even in a single-digit milliseconds. And so all of our layers need to be extremely, extremely responsive. So what we did, we took a 48-node M2.4 XL cluster that was also fronted by 36 M2X large nodes running our EV cache. It's an extension on top of Memcached. We then compared it to a 15-node SSD cluster and drove the same traffic with the same application. And the results were just amazing. We found that we can achieve the same throughput at lower latency and at half the cost. And the cost savings come not just because we needed less Cassandra nodes, but because we could eliminate the whole cache cluster that was in front of it. As a side benefit, we also get simplified architecture, less layers to break. So we're using basically as many SSD nodes as we can get our hands on. We use them in many of our production clusters, and they help a lot. I hope to use even more soon. I think Adrian already apologized for that. So some interesting factoids about Netflix use of Cassandra. So we run over 50 clusters in production, even greater number in test. Large chunk of those clusters is multi-region. That means the ring actually spans multiple regions, and we replicate data globally. We have one cluster that actually spans at least 4 regions and replicates some of our global configuration data that we need to be consistent. Over 100 terabytes of data stored across all of our clusters, close to 800 nodes, growing day by day, week by week. The largest cluster that we run, that's a cluster that hit 1 million writes a second, is currently 72 nodes, stores about 30 terabytes of information. And this is the read and write through traffic that it handles. What we didn't include in the slide, and that's even more impressive number, that Greg and his team handles all of this with 3 people. So there is incredible amount of automation and tooling that we wrote around Cassandra and how we manage it, how we run it, in order to do that. Otherwise, we just would not be able to scale it. We would not be able to hire and train people fast enough with our growing needs of our persistence layer. So, sorry, I think, oh yes, okay. So what does the future hold for Cassandra at Netflix? Well, for a lot of the small applications within Netflix, they don't need to do anything complex. They just simply need to do basic CRUD operations. So for those teams, we'd like to alleviate even the small, I don't want to even call it complexity, but small task of incorporating our Java client into their applications. They should be able just to make a simple REST calls, do what they need to get done, and don't really even bother to understand how it's configured or provisioned underneath. So at least internally, initially, we're planning to introduce Cassandra as a service. As Greg mentioned, our current policy is to over-provision and to provision dedicated cluster for each little application. Some applications don't use persistence layer very heavily, and they can actually go into a multi-tenanted shared cluster solution. And that will optimize things for us. We'll have less clusters to run, and we'll also optimize the utilization of those clusters. There will be less waste. We're very much looking forward to into Cassandra 1.2 vNode. We're already auto-scaling large chunk of our infrastructure. But large chunk of our infrastructure are stateless services. Now, wouldn't it be cool if you could scale your persistence layer based on your data size changes or read-write throughput changes? Planning to have that sometime soon. Pream, the management coprocess that Greg mentioned. We wrote it to alleviate some of the biggest operational pains. How do you bootstrap a cluster? How do you backup restore it? How do you configure it? How to ensure the token range distribution is uniform? Over a year and a half of using it, we found some use cases where we can greatly improve. And so we're planning to put quite a bit of attention into Pream, which has been open sourced earlier this year, and make it even more powerful. Carry some more advanced use cases and also expose much more metrics via GMX. We have a tool that's currently in development, and hopefully it will be open source soon as well, that will make our Cassandra clusters self-healing, self-maintaining, and again, take that human part of the maintenance even more out. At this point, I'd like to segue a little bit into our open source efforts. So as Greg mentioned, Astynx, our Java client, and Pream, the management coprocess, are open source. And they're at our GitHub site at netflix.github.com. The tool that he showed you, lots of pretty circles and a few others, called Cassandra Explorers internally, it will be coming to open source as well. We find it extremely useful. I hope you will as well. Again, I'd like to sidetrack a little bit and talk about our open source efforts. I hear this question a lot. Why do you open source it? Why do you take something that a lot of you engineers spent a lot of time developing and just give it out there? Well, there are many motivations. But the main one is that we as a company benefited from open source software for many years. Whether it's Linux, whether it's Apache, Tomcat, we'd like to pay it back in kind. But it also helps us as well. As Netflix was a fairly early adapter of AWS. And at that, we paid the pioneer penalty. We learned a lot of lessons. And we developed some best practices to deal with them. We'd like to share these best practices so many more can benefit from that. It does help us indirectly by hire and retain the best engineers out there. If you're a great engineer, Sometimes you're not just satisfied with making an impact on your product, as exciting as product as Netflix may be. It's really exciting to be able to say, look, the stuff that I developed actually can help companies way outside Netflix and help others. And that was the case with our deployment console, Asgard. Obama for America campaign used it, and we heard it helped them. Helps us indirectly in another way. Our code quality went up immensely when we started open sourcing our components. Apparently, it's one thing to know that 5 other people inside your company will look at your code. It's a completely different thing if you know that thousands of eyeballs will judge your code quality out there. What we found is that as we started open sourcing our infrastructure, suddenly people say, no, it's not ready yet. It's good enough for production, but not quite good enough for GitHub. I'm going to restructure it. I'm going to clean it up. I'm going to update documentation. Then it's going to be ready. We benefit from it as well. So if you go to netflix.github.com, you will see all the pieces of infrastructure we open sourced so far. More is coming. We use them directly. These are not the forks or branches. We don't have anything specialized inside. What we open source, we use directly. This is not my Netflix movies recommendation page. This is our site for those of you who have not seen it. And here you'll find a Styanax and Priam that we mentioned for Cassandra. You also find their equivalents for Zookeeper, which is another technology we use internally. It's called the Curator and the Exhibitor, as well as many others. Asgard, of course. Every developer at Netflix uses this console to deploy and configure the software. Simian Army, most famous member, which is Chaos Monkey. We do have a presentation right after this on all of our Simian Army members. That's pretty cool. And many others. I highly encourage you to visit it and see which pieces of our infrastructure may be useful for you. And of course, we welcome all contributions and feedback. So in conclusion, Cassandra has been really high-performing and durable persistence layer for us in AWS. It is flexible enough to serve most of our use cases. Not all, but most. We don't treat it as a one-size-fits-all, but it is flexible enough to satisfy most use cases. AWS offerings such as S3 and RDS help us to create a complete persistence solution to serve all of the company needs. And Cassandra performs well for us. Sometimes we needed to front it by cache, but on SSDs, it's performed just amazingly. Now, I'd like to leave you the final note with a disclaimer. Just because Netflix does it, doesn't mean it's right for you. So do your own evaluation. We do hope that all the stuff that we talked about and open sourced will be useful for you, but make sure you do your due diligence. That's it. You can follow us on TechBlog, and please visit our open source site. Here are some Twitter handles you can follow as well. And at this point, Greg and I can take any questions you have.